Hello everybody, here's me doing applied maths once again because everyone asked for my homework, so I might as well do videos explaining it. If you want to read the question, it's there, you can pause it, but the basic idea is that you want to find the tension in the string and the acceleration of the particles in the pulley. So what you need to remember is that the acceleration of the 20 kilogram pulley is going to be the average of the acceleration of the other two particles, because it has two strings pulling it up, while the others only have the one string tension pulling it. So the particles on the table each have their weight force pulling them down. Well, everything has their weight force pulling them down. So the 10 kilogram has 10 G's, 6 has 6 G's, and the 20 kilogram has 20 G's. But the two particles on the table have their resultant forces pushing them back up, because they're not moving up or down. The table is pushing that force back up on them. So then, the other forces affecting the particles on the table is their friction, and the question says that the coefficient of friction is a half. So friction is equal to mu times r, so the coefficient of friction times the resultant force. So we've got friction is equal to half of each of the forces, half of each of the masses. So we've got 5g for the 10 kilograms and 3 for the 6 kilograms. They're both accelerating towards the 20 kilogram mass. At the 10 is at a meters per second squared, and the 6 is at b meters per second squared. They're both at different speeds. So now the tension in the 10 kilogram mass is pulling it in the same direction as its acceleration. So t minus 5g, its friction, is equal to its mass times its acceleration, 10a. So you can rearrange, find a is equal to t minus 5g over 10. Then you do the same for the 6 kilogram mass. Its tension, which is pulling in the same direction as its acceleration, minus its friction, which is pulling it in the opposite direction, is equal to its mass times its acceleration, 6b. So you can rearrange, find that b is equal to 3g over 6. So then for the 20 kilogram mass, it's got its weight force pulling it down, but then it's got the two tension forces pulling it back up, going opposing its acceleration. So it's got 2t, so minus 2t is equal to 20, its mass, times its acceleration, which we said earlier was the average of the other two. So it's a plus b over 2. So then you can just multiply out and rearrange, or multiply out, divide by 2, you get 10g minus t is equal to 5a plus 5b. And here's where that value for a and b come in handy. You can just rearrange using those values. So what's the word? Put them in, and then you'll have an equation. Substitute. You'll have an equation with just one unknown, t. So then you get 10g minus t is equal to t over 2 minus 5g over 2 plus 5t over 6 minus 15g over 6. And then you can just put all the g's on one side, all the t's on the other, and you'll find that 45g over 7 is equal to t. Actually skipped a step there. It's going to be 15g is equal to 7t over 3 when you bring them across. So you can just multiply by 3, divide by 7 to find t on its own, and then you find t is equal to 63 newtons. So then to find the acceleration of each, for the 10 kilogram mass, its acceleration was a, so you just use your value for a of t minus 5g over 10. So then you'll just stick in your 63 newtons is equal to t, and minus 5 by 9.8, because that's g, is equal to 1.4 meters per second squared when you divide by 10. Then you do the same idea for the 6 kilogram mass. B is its acceleration, b is equal to t minus 3g over 6. Put in your t and your g, and you'll find that b is equal to 5.6 meters per second squared. And then you find the average of those to get the 20 kilogram mass's acceleration. So 5.6 plus 1.4 is 7. Divide that by 2, you get 3.5 meters per second squared. And then you have the acceleration for each of them. Thank you so much for watching. It really does mean a lot, and I appreciate all criticism and comments. So if you've got any suggestions, just comment down below. I'll read it all. Thank you very much.